All right, we'll try this again. There's an overhead announcement. It kind of ruined the last video. All right, so for this one, we're looking at a 9x squared minus 49y squared. And the special case here is that this is a difference of perfect squares, right? 9 is a perfect square, x squared is a perfect square, 49 is a perfect square, that's 7 squared, and y squared is a perfect square. So this is what we call difference of squares, and anytime we have a difference of squares, we take the square root of the first one. Square root of 9 is 3, square root of x squared is x, and we can do subtraction for this one. Square root of 49 is 7, square root of y squared is y, and then we're going to write the exact same thing almost in the other parentheses. We're just going to put a plus between our values instead of a minus. And that way, when we go and multiply through, we'll get our 9x squared. We'll get a negative 21xy, but then we'll get a positive 21xy. They cancel each other out, and then we get the negative 49y squared. You can do this the same way that we've done other ones. Okay, so our A value is 9, our C value is 49. We don't have a B value. I mean, we do. Our B value is 0. But if we do 9 times 49, we get 441. And we need two numbers that when we add them together, we get a 0. And so the square root of 441 would give us 21. And so if we had 21 and 21, then that would 21 times 21 is 441. All right, that should be a negative 441. So because it's a negative 49 times positive 9, so negative 441. So one of these is negative and one of these is positive. Negative 21 plus 21, that's 0. Negative 21 times 21, that's negative 441. And so we could write this as 9x squared minus 21x plus 21x minus 49y squared. And just like we've been doing, we can factor these out. Greatest common factor is 3x right here, and left inside is a 3x minus 7. And then over on our other side, greatest common factor is a 7. And then we get a 3x minus 7 on the inside. Sorry, 7y. I lost a y somewhere. Oh yeah, 21xy, 21xy. So that's a 7y. 3x, so on the inside, so one of our sets, so we got the same things, right? We got 3x minus 7y. And we got on the outside of the parentheses 3x plus 7y. So you can still do it the other way, but if you recognize that this is a difference of squares, then it kind of speeds things up if you know the pattern. If you're not sure about the pattern, go ahead and do it the normal way, the way we've been doing it. It won't hurt you any. It may take a little bit longer, but that's okay. And I probably shouldn't have erased all that just now. But I can't bring it back. You go ahead and do it the other way, even if it takes you a little bit longer. If you're more comfortable with it, then that's safer. All right, I'm going to move on to B now, and I'm not really going to stop and do these all the... Okay, maybe I won't because it's doing weird things. All right, B, 4x squared minus 56x plus 196. First thing I'm going to do is I believe all those numbers, I know the first two, I believe all those numbers are divisible by 4. And so I'm going to go ahead and factor out a 4. So I'm going to write this as 4 times, we've got x squared minus 4 goes into 56 14 times. And goes into 196 49 times. Okay, so now I've got the 4 on the outside. X squared minus 14x plus 49. I can recognize that this is x minus 7 times x minus 7, or x minus 7 squared. X squared, x times x is x squared, minus 7x, gives me the negative 14x, and then negative 7 times negative 7 is positive 49. So this would be the factored form of that one. I factored out the greatest common factor first, which was a 4, and then saw that my middle term was 2 times 7, and my final term was 7 squared. And so I could write this as 4 times x minus 7 squared. And again, this is a special case. You don't have to do it this way. If you're more comfortable doing it the other way, then go ahead and do it the other way. All right, the last one, which is number 2a. I guess I haven't really been labeling these very well. 2a is 2x squared minus 28x plus c. And we want to find some c value that is going to give us a perfect square pattern. So what we're going to do is I'm going to factor out a 2 from all of this, and that's going to give us x squared minus 14x. This looks fairly familiar, plus 1/2 c. Okay, because I want to be able to get, I factored out a 2. That means I have to cut my c in half as well. What I need here, this is very, very similar to what I had in the last one, where I have if I divide my middle term into 2, I get a -7. And if I multiply -7 times 2, or times itself, I'll get a positive 49. And so what I need this 1/2 c to be, 1/2 c is equal to 49. If I multiply both sides by 2 or divide by 1/2, which is the same thing, we would get c is equal to 98. Okay, and so then I can, c is 98. Really, I've found the answer, but just to rewrite the whole trinomial, we'd have 2x squared minus 28x plus 98. And that is a perfect square trinomial. It's the same thing as 2 times x minus 7 squared. Okay, and again, I'm just trying to go through these videos so you have kind of some steps to compare what your work is looking like, also to correct errors. If you have further questions, please let me know, and I'm happy to go over them or go into more depth on them.